Now we're going to talk about rate of change and average rate of changes. So when we think of a rate of change, we're thinking about the slope. That's what you should think from Algebra 1. So rise over run. And that's the steepness of the line. So if we look at this graph right here that we have, it's going up and then it's going down. And it's kind of flat at the top. So this means that it's increasing here and decreasing here. That means we have a positive slope on the left side and a negative slope on the right because it's going up and then it's going down. And then if we're looking right here, it's like perfectly horizontal. So we're talking about it not increasing or decreasing, and that's okay too. Remember, when a function is increasing, the slope is positive. When it's decreasing, it's negative. And when it's horizontal, it's just 0. And to find a slope or an average rate of change, so we need to keep those things in our heads as the exact same thing, slope equals average rate of change, we're going to use this formula. It's just rise over run. Change in y over change in x, f of b minus f of a over b minus a. So let's practice this. I've got a few types of problems. We've got graphs, we've got tables, we've got equations, and we have a word problem. So naturally, we're going to cover all of these things in a wonderful, wonderful way. So in example 1, we're trying to find the average rate of change from 3 to 6. So it's always going to be something of 6 minus something of 3. And we're going to use these different equations. So the way we find those numbers is varying depending on what we're given. So for example, for f, we'll use the value at 6 and we'll use the value at 3. So if we're using the value of 6, well, first I'm just going to write the formula. We're going to have f of 6 minus f of 3 over 6 minus 3. I always write down the formula, and it's always the bigger number minus the smaller number. Doesn't really matter, but it helps with the math because oftentimes that's going to give you an easier number to deal with. In our case, f of 6 was 0, and f of 3 was 15 if you're just looking at the value on the graph. Well, that means we have negative 15 over 3, which is negative 5, and that's it. For g, so we're going to use the table. So we're looking at what's happening at 6 and what's happening at 3. We're not really interested in what's happening everywhere else. We're just worried about those endpoints of our interval that they're giving us. So in this case, we'll have g of 6 minus g of 3 over 6 minus 3. G of 6 is 18. G of 3 is 48. 18 minus 48 is negative 30. And negative 30 over 3 is negative 10. The most complicated type is when you're given an actual equation, because now you're going to have to do some math and you have to pay attention to your signs and your parentheses. So we're going to have h of 6 minus h of 3. Notice those equations did not change. The only thing that changed were the functions themselves and the letters in front. Now remember, h of 6 means that we're taking 6 and we're plugging it in everywhere you see an x. So we'll have 6 squared minus 6 minus 2. We're subtracting h of 3, so we'll have 3 squared minus 3 minus 2. And that's all over 6 minus 3, which is 3. Now we have to do some math, some arithmetic, right? None of which you need a calculator for. You don't need a calculator. 6 squared is 36, minus 6 minus 2. 3 squared is 9 minus 3 minus 2. 36 minus 6 is 10. It's 30, sorry, because you get down to the 10. So it's 30 minus 2 is 28. 9 minus negative 3 and negative 2 are negative 5, so 9 minus 5 is 4. So this is 24 minus, so it's 24 over 3, which is 8. So if we're putting this in order from least to greatest, we're going to put the least first, so that's going to be g. So that means g of x is less than, the next one is f, because that was negative 5, which is less than h. So that would be the final answer. So that's how we deal with all the different representations of how you can be given an equation. Then we have to be able to answer word problems. You will get word problems to deal with. I promise. You will. So let's look at this, right? So what is the average rate of change from 2010 to 2014? And this table is showing the average price of gas in dollars per gallon in the United States from 2010 to 2015. So gas prices, they plague us always. You might not have to deal with that as much because you might not drive a car, but your parents do. So if we're going from 2010 to 2014, that means we need to know the value at 2014 and at 2010. Okay, so those are the two numbers we're using. So we're going to have change in Y. So that's going to be the value at 2014. So that's 3.42 minus the other one over 2014 minus 2010. We do some little math. So we get 0.58 over 4. And then we get 0.145. So that's the average rate of change in the price of gas from 2010 to 2014. Now we'll do the same thing, but for 2010 to 2015. So I'm going to change my numbers. I'm going to use 2010 and 2015 now. Same process though. I'm going to use the bigger one first. And I mean the bigger year, not necessarily the bigger number, because it doesn't always end up being a bigger number. And when we do that math, I'm just going to show you what we get. It's divided by 5, which simplifies to negative 0.066 dollars per gallon per year. Last one. Assume that the average rate of change from 2011 to 2012 continues through 2025. What do you predict the price of gas to be in 2025? So we're going to use the 2011 and the 2012 values, and we're going to have to find the average rate of change of the price of gas between those 2 years, and then apply it to what happens in the future. So let's first find the average rate of change. So we have 3.69 minus 3.58 over 2012 minus 2011. And fortunately, that's just a number. That's just 1, right? When you divide anything by 1, you get the same number. So we're really just finding the difference here, and that's 0.11. So that's 11 cents. That's 11 cents. So it's going to grow. That means it's going to increase by 11 cents every year from 2012 to 2025. So how many years are between 2012 and 2025? Well, let's do the math. 2025 minus 2012. That ends up being 13 years. So that means we're going to take 13 and multiply it by 0.11 because that's how many times it's going to increase by 11 cents. So 13 times 0.11. And then we're going to add our original number, which was, and we're going to say we're going to lift off at 2012. 3.69, so that's $3.69. So it's increasing by 11 cents for that total of 13 years, every year, once a year. And then we're adding it to our initial value because that's where we are starting, or that's where we left off. So assuming it's increasing at the same rate, right? You're just adding the rate. It's a linear equation. The slope is actually 0.11 because that's the rate of change. 13 is the number of years after 2012, and 3.69 is your initial value because that's where you left off. So it's just a linear equation, right? We've done that before. You took Algebra 1. So whenever we do all of this math and we throw it into a calculator, or you do it by hand because you're very, very intelligent and you're very capable of doing that, you get $5.12.